Ferris, can you hear me? I think you're still muted. Hi, Ferris, can you hear me?
Yes.
Hi. Yeah, Ferris. Okay. I just thought that there is something wrong with my mic and I was not able to hear you. Just let me check the other setting of mic. Let me know if you are able to hear me.
Yes, I can hear you. And let us see. Yes, okay,
Right.
this looks
Okay,
good.
I'm also putting my video on. Okay, great. I hope your picture has come clear in this virtual background.
Yes,
All right.
it's,
Okay,
it's
great.
a little bit clearer now.
So in 3 minutes we are going to start. Did you get a chance to go through the video that I shared? It is not edited. It is just because yesterday the whole morning, day, and till evening we had sessions, so we did not get a chance to edit it. So when we are putting it on YouTube and I'll be sharing the edited version, it will have a proper branding and slide and everything will be there.
It was okay. I have seen it. Maybe there is a small glitch with one question, but in general,
All
it's
right, you can let me know. I mean, you can just give me a timestamp of where you see the glitch and we'll remove it.
no. It's fine. You can keep it. It's around the minute 41.
All right. Okay. Sure. So I think people have already started joining. We are going to start right on time.
So great conference so far.
Oh, thank you. That's great. I mean, it's very encouraging to have participations from speakers like you and people all around the globe, and that has really helped us to, make it grow like how we expected. So, thanks to you all.
Yes, and we are very much keen on transferring our course to lab docs.
Oh, thank you. And let's start. And let me know if you're able to see my screen. Yep, it has started. Just give me a moment. Yep, are you able to see my screen?
Yes, I can see that. Yeah.
Okay. So I think the event is also. I'm going to start the recording now.
Mhm.
I'm going to share the streaming link with you on chat, Ferris. I mean, if you want to share this with anyone who could join, if they have not registered on Zoom, they can check this link and they can join it from YouTube. I think you can see the link which is there on the chat.
Yes, I have seen it. Do you want me to share it on my social media channels?
Sure, if you can. I mean, that will be great so that it becomes easier for anyone to just go and visit through YouTube.
Okay, let me share it.
People are still joining it, so maybe we'll give a couple of more minutes for everyone to settle down, and we can start in 2 minutes. All right, I think we are good to go. Am I audible, Ferris and Siddesh?
Yes, you are audible.
All right, very nice. So, good afternoon, everyone, if you are joining us from India. And good morning to people who are joining from UAE and Middle East and Europe. Since yesterday, we have had your support, and it's been awesome. We have had people coming and joining from all across the world, and we have speakers and companies coming to us and talking and sharing their insight about various topics, emerging topics such as Industry 4.0, e-mobility, autonomous vehicles, smart cities, panel designing, instrumentation, and we have had the privilege of people joining from Udemy and LinkedIn. So Ferris is one of our esteemed speaker who is joining from Jordan, and he's a very popular Udemy instructor, and he's been conducting and helping people to understand what is e-mobility and autonomous vehicles, railways, and he's been doing a lot of awesome stuff all across the globe, and he has helped many of them. So we started this event. We planned this event with one motive, that we are going to bring people from all across the world who are working in core engineering sectors and science sectors, and can help them to understand what is going on in the global environment and how things are changing since COVID has started. What are the opportunities? What are the things that they can learn? How can they leverage their career or whatever they have learned in the professional journey? Not only they can start something of their own, but they can also work for someone, and having these skills will always benefit, because these are the skills that are really upcoming, and this is what is going to change the shape of the world and how we live in this world. So that is what was the objective of this event. We are having 4 tracks in this event, and we are running parallel tracks like workshop, then career tracks. So people who are looking to apply for jobs, they can apply through our collaborative partners and industry partners. And if they are looking to hear from speakers like Ferris and Jonathan, and international, get an international exposure, they can get. Not only that, there are a few benefits that you can have if you are joining here. So, such as, you not only get to hear from the international speakers, you can listen to the workshops and attend the workshop by IDC, EIT Australia, ThinkPrint, and there are special session that we have just concluded, which was from, again, a very acclaimed international speaker, Shweta Thapa. She joined from New Jersey, and she spoke about how women can start their 3D printing journey. People who are staying with us and staying till the end for our workshop, they are sure to get goodies and workshops or courses worth 50,000. If they have stayed with us since yesterday, they can sure to be winning these free courses, which is worth around 50,000 rupees uh, from Udemy and as well as from IDC. So we are reaching out to the fag end of the event, and Ferris has joined us, and I'd like to tell you about what we do at LabDocs. So LabDocs is an e-learning platform, and we have collaborated with various platforms and various international speakers to talk and teach in emerging technologies and sectors. So we are helping learners to acquire core engineering and entrepreneurial skills. All our workshops and courses have two angles. One is technical angle, and the other one is entrepreneurial angle. So these are some of our focus areas. You can see that these are the areas which is upcoming and can help anyone who can acquire any skill on these sector can sure to avail a lot of bounty, like digital manufacturing, robotic, instrumentation and control, e-mobility, autonomous, and so forth and so on. Right. So as I told you that this is how the schedule looks like. We are right now talking about e-mobility and building opportunities by Ferris, and after that there is going to be an interesting session about from Anirudh. He is our industry partner from ThinkPrint. We're going to talk about how to adopt 3D printing technologies in sectors like drone tech, robotics, and Industry 4.0. And at the end of the session, we have a workshop by Udemy instructor Arfaq Ahmed. He's going to talk about instrumentation and panel designing. So Faris Nasser, my very good friend, Faris is joining us from Jordan. He is a founder and business executive of farisnasser.com, and he's been a leader number one in Jordan and UAE, been teaching a lot of stuff in building and construction and from civil engineering. He has done his postgraduate research from University of Birmingham, and he has been awarded the Emergence FZD manager at Emirates German Building Materials. And this is some of the few experience that he has. So I would request Ferris to take over and share his story about his journey and about the wonderful topic that we have chosen. So over to you, Ferris. I'm going to stop sharing my screen and so that you can start sharing your screen.
Thank you, Amit. This is a very kind introduction from your side. And every time you actually humble me with the way you talk about my profile and about my previous experiences. So these days I run farisnasser.com, which is a tech seeds incubator that aims to provide a new path for the young generation, providing them with some visibility to some of the ideas. So without further ado, let's have a look at the presentation that I have prepared for you about building opportunities in electric mobility. And the way I would like to do this presentation, I would like to do around 40 minutes of continuous conversation, continuous explanation. Then we'll go to questions and answers. So opportunities in e-mobility. Is there any opportunity in the world of autonomous mobility? We can see this with the stock prices of Tesla, that prices that went to more than $700, and we can see it with the other electric companies, so electric cars companies. So in reality, maybe there are a limited number of sales of vehicles, but in the stock market, many people are betting on the electric mobility boom. And this is also, we can see this on a policy level as well. So opportunities in e-mobility. So the presentation, I will be providing you with a little bit of introduction about myself and about some of the work that I'm doing. Then I will be talking about the main content of our course that we are providing in Udemy. This course is titled Autonomous Cars, Drones, and Electric Mobility. And you can see this from the three pictures on the right side of the presentation. We see a lot of synergy between these forms of transport. Then I will be talking about opportunities in electric vehicles. Where are the opportunities for the future and which areas we expect to grow, and how do we see our autonomous, our electric and hopefully autonomous vehicle global fleet growing or expanding. I will talk about the electric vehicles ecosystem. This is a socio-technical change that it has its own set of requirements. You have charging infrastructure. You have the electricity grid. You have many changes that is coming with this electric mobility. You have the oil prices, the fuel prices. So electric vehicles will provide a socio-technical change that will impact many industries. Then I will be talking about EV policy. What are the policy these days on electric vehicles, and what is Vision 30 at 30, which is about providing 30% of the global fleet, of global cars fleet to become electric vehicle, and by the year 2030. Opportunities and innovation using electric vehicle technologies. Then I will be talking about starting a career, entrepreneurship in electric vehicles, and I will conclude. So, about me, I have a bachelor degree in civil engineering from the University of Jordan. I have a master's degree in railway systems engineering from the University of Birmingham, one of the early builders of civil drones in the Middle East. And I have an online degree from the University of Toronto in autonomous vehicles. and I have floated the idea of autonomous guided bus application. What brought me to electric vehicles is actually the autonomous cars course. I thought there are a lot of synergy between electric vehicles and autonomous vehicles, because I think the future will be a combination between electric and autonomous vehicle. Of course, the first and best seller of the railway course on Udemy. So if you text railway on Udemy, you will find my course as number 1. And also I have made the first Arabic autonomous systems course on Udemy too. There are around 400 million people speaking Arabic in the world, and they might find this course handy. What is distinctive about me and what I'm doing these days is the amount of innovation and amount of prototypes and amount of ideas that I am trying to bring to the market. So I have more than 10 years in creative innovation, building innovative prototypes and presenting them to various stakeholders. And maybe during the COVID days, I started doing this online education, and we started to see the blessing of online education, because you have the knowledge is expanding rapidly, and now you can access knowledge much quicker, much faster than ever before. So the few pictures about me. This is me inside Istanbul Metro. This is me building our first drone. And this is the other me holding our Inspectro device, which is a mobility inspection prototype that we have developed. This is the course, so please go to Udemy, Autonomous Cars, Drones and Electric Mobility, Top Track 2021. And we have a discounted coupon for you today. It's under Cars Passion. So if you enter the Cars Passion as a coupon code, Cars-Passion, you would get a discount. In this course, we teach about autonomous cars, drones, and electric mobility. So hopefully, as a young student or as a professional who would want to join this, revolution in electric vehicles and be part of 30 and in the year 2030, and increasing the global stock of cars to become electric vehicles. Now there is around 1% of the global cars fleet is electric. By the year 2030, so it's around maybe 8 years from now, it will become, there is a vision to make it 30%. It's not an easily attainable vision, but it can be done if we have spread awareness and knowledge about the benefits of electric vehicles. So this is the course. Please go to Udemy and get your discount, Cars Passion. So about the course content, what do we teach? We teach in three topics. We teach electric vehicles, we teach drones, and we teach about autonomous vehicles as well. So in the electric vehicles, we talk about policy, we talk about principles, we talk about the components of the powertrain and business models. In drones, we talk about principles, we talk about components, and we talk about software and simulation. Maybe you want to be part of the drone software revolution. There is many drones need extended capability using computer vision and using other machine learning software. So the drone software is a booming area as well as the electric vehicles. Autonomous cars, also another area where it might have a potential revolution. And in this section, we talk about policy, principles, components, software, and simulation. So this is the components of our course. I hope you will be enjoying it. It's a great value for money, and you will find it a very interesting and engaging course where we meet weekly in our questions Thursdays and innovation Wednesdays. So now let's talk about opportunities in electric vehicles. And you can see on the right side the shining red Tesla and another car from the company Bike. So this is the current market situation. There is a great competition between Chinese and US automakers to enter the world of autonomous electric vehicles. in the year 2019, there was around 7.2 million cars that are electric. This was around 1% of the global car stock, and there is a vision to increase this stock to 30% by 2030. This is 30 times what it is now. So there is a push for electric vehicles on a governmental level because of climate change and because of environmentally friendly policies. So electric cars provide a solution for this. But would this happen? What I want to talk about, that electric vehicles is a socio-technical system, and the socio-technical system would go through a gradual change. It starts as a technological niche, and this is where we see that Tesla has started as a sports car, and then it's tried to add the benefits of the additional benefits of the car to replace the old car. You can't replace a thermal car with an electric car because it delivers the same function. This has to go through a socio-technical change, and socio-technical change need the society to buy in and to adopt the electric vehicles. So there was around 30% around the year 1900. There was around 30% of the global car stock is electric, and many people thought that electric vehicles are the future, but the thermal vehicle came and took over. So we need to understand that the changes that is happening in electric vehicles can be described under socio-technical change, which is influenced by society values, by the technology itself, that it should be much better than the previous technology, and it just can't replace it. It can't be a gradual change. So there will be many factors that impacting this socio-technical change. So the first prototype of an electric vehicle happened in the year 1830, and there was around 30,000 electric vehicles around the 1900, and this is the peak stage of electric vehicles. However, the stop of electric vehicle happened after 20 years with the emergence of thermal vehicle. Around the year 2007, we have a new resurgence of electric vehicles, and in 2014 we have 500,000 electric vehicles, and in the year 2019 we have 7.2 million. So electric vehicles are expanding, and we are seeing the growth, but we are not sure if this growth will lead the socio-technical change or not. So to understand electric mobility, you need to understand the ecosystem. The ecosystem around electric vehicles, you need to apply well-to-wheel analysis to meet the environmental goal. To tackle climate change is not only about electric vehicle, it's about having clean energy. It's about having clean energy at the generation level and at the consumption level. So, and this is what we call well-to-wheel analysis. So, having clean energy, producing clean energy from renewables, wind turbines, or other sources of clean energy, and in the consumption in the tank, not producing CO2 emissions on the vehicle itself. So to understand this, the journey of electric vehicles, you need to understand that you have to go from energy generation, distribution, as well charging stations and electric vehicles. So all of these systems have to place a fundamental part in the ecosystem of electric vehicles. So the electric car industry, you can think about it as, if you want to think about the ecosystem from an industry level, and you can see the Tesla Gigafactory here, you can think about it as an upstream, central, or downstream. So upstream, you extract the materials that are being used for electric vehicles, and we can see this with rare earth metals that enters into batteries. And so many lithium ion batteries require raw materials. So if you work in a mine, in a mine, you can be working on the upstream side of the industry. Central, you can bring all of these components and manufacture them, and downstream, you can be selling the final product to the consumer. You can be manufacturing a sub-component on a central level, and you can be on the downstream side where you are delivering the final product. So the drivers for electric vehicle support by any country will be about the existence of an automotive industry. If you have, for example, big factories, they will see that supporting an electric vehicles will be an added asset to their current manufacturing capital. Transformation of energy storage industry, for example, battery, upstream existence of an industry, extraction of transformation of raw materials, and existence of industry that is producing electricity from renewable sources. Those are major drivers that contribute to the revolution of electric vehicles. And maybe we see this highly in Europe, where you can see Norway is one of the countries that adopted electric vehicles quickly, because many of the drivers exist within their country. And maybe you can see less in, for example, in an oil producing country, because they think that the electric vehicles might be, of course, it's an advantage for the environment, but they don't have the industrial base that support this revolution. So the electric car industry have it is supported or aligned with the environmental and emission goals. So the electric car industry, the car has to reduce its CO2 emissions to acceptable levels. And to do this, we do not only reduce our CO2 emissions at the production level, but we do this on the product life cycle, from the manufacturing to the extraction of raw materials. We calculate our energy footprint and our CO2 footprint, as I said before, on a well-to-wheel analysis mindset, because we need to reduce CO2 emissions on from the well to the wheel. We need to drive our environmental goals, not only at the production of electric vehicles or the consumption or the usage of the car, but on the whole life cycle cost. So let me tell you more about well-to-wheel analysis. So there is a conventional sector, and there is an alternative sector, electricity sector and hydrogen sector. These are the main sectors that are producing energy. So if we think about the analysis from well to tank, so the energy that reached the tank of the well, this is oil and gas, petrol and diesel. In the conventional sector, means it's not, it produces CO2 emissions, so is not clean. It can be another sector, which is the alternative sector, using sugar cane, ethanol, vegetable oil, biodiesel, coal. And also this is not clean. When we reach electricity sector, where we produce energy from renewables, nuclear, we started to reach a cleaner energy from the well to tank. And on the hydrogen sector, we can produce hydrogen. Hydrogen either from natural gas, biomass, or electricity to hydrogen. So it depends on from where we get our energy, and is this source clean? Is this source environmentally friendly, or this source is not environmentally friendly? And we think about this on a life cycle cost, or not only at the vehicle side, but at the total, but at the whole cycle. Then you would be thinking tank to wheel. So of course, conventional sector will use petrol vehicles, which are not clean. Then the alternative sector might use biodiesel. Also, can be a little bit cleaner. Then you have the electric vehicles, which is the cleanest and least harmful for the environment, which is produced energy from the renewable sector and used electric vehicle at the source, so they produce no CO2 emissions at all. So let me just go through some of the graphs that affect our well-to-wheel analysis. Of course, there are different types of electric vehicles and there are different types of cars. So if we look at the petrol car and if we look at the CO2 emissions or greenhouse gas emissions, so here you can see this column here, you can see most of the CO2 emissions are coming from tank to wheel, and there is some part coming from the production of the petrol itself, wheel to tank. So the blue part is the production of the energy that was produced, the greenhouse emissions that was produced in the production of petrol, and then the orange column is when it was used in the vehicle. And you can see as we move down from petrol, diesel to petrol, to diesel to hybrid, to diesel hybrid, to plug-in hybrid electric vehicle, we can see that the CO2 emissions are down. If we look at the electric sector and we have put the petrol and diesel here, we can see there is only CO2 emissions that are produced at the energy source, and there is not much produced on the usage of the car itself. Well-to-wheel analysis. So we can look at biodiesel, bioethanol. We look at different combination and which one is the most environmentally friendly and which one has the lowest greenhouse gas emissions. Of course, the cost calculation and the feasibility calculation is something else, but we try to find the most environmentally friendly solution by looking at the well-to-wheel analysis, and this is fundamental part of the electric vehicles argument. Of course, not only greenhouse gas emissions or CO2 emissions, also we look at acidification. And here there is acidification that comes from the battery. And you can see here, this is the comparison between a passenger car, a diesel car, and a gasoline car. And we can see where is acidification coming from. Is it coming from the electricity itself, from the battery, from the components? We look at the components, and while looking at the components from a life cycle cost, we can see that the acidification that is coming from electric vehicles is high. You can see the battery that is contributing to the acidification of the environment. So electric vehicles is not only about greenhouse gas emission, but they can also produce some acidification to the soil. And we look at different countries and what they are doing in terms of their energy mix. We can see that the EU 28 mix producing producing this amount of greenhouse gas emission, while France is much lower because they have 72% of their energy coming from nuclear. China is higher because they are dependent on natural gas and coal. And of course, you see the comparison between different countries to give you a perspective on the well-to-tank, at least the well-to-tank part, and how clean is the country in terms of producing energy, how environmentally friendly. Of course, the numbers are changing year by year, and there is a huge push for the environmental agenda. Before I continue on talking about the ecosystem of electric vehicles and the powertrain and the different types of electric vehicles, let me have a look at the chat and see some of the questions that you sent. Okay, first poll coming up. So can we have a poll now? The poll questions: are you familiar with e-mobility? Please state your profession. True or false, the first electric car was built over 100 years ago? That's a good question. So we started to see some of the answers. So So we can read the results. So some of you are familiar with electric vehicles, like 57%. Most of you are engineering or science students, and you got the first electric car was built over 100 years ago. 71% of you got it right, it's true, and 29% got it false. So I will end the poll so we can carry on with our presentation. Here I share the results with you, and we continue with our presentation. So, and it's now important that after we talked about the environmental agenda and how we need to think about well-to-wheel analysis and the consumption of and the CO2 emissions productions in electric vehicles, now it's time we talk about the electric vehicles ecosystem. As I said before, this is a socio-technical change that is associated with changes in values, changes in the society norm that is producing a superior technology than the current thermal car. So it will take some time to be adopted by the society as according to the laws of socio-technical changes. Now, the electric mobility ecosystem starts from the generation to the charging point to the electric vehicle itself. So about this, we need to know to understand the different vehicles we have. So in the left-hand side, you see the internal combustion vehicle or the thermal vehicle. It has energy reserve, which is the fuel tank, and you can fill it with petrol. The petrol goes to the internal combustion engine. It produces a spark, and through the heat, it produces the movement of the vehicle, and it produces the rotational movement. So this is the conventional car. If we look at the electric vehicle itself, you have a battery pack, and this battery pack is not connected to internal combustion engine, but to an electric machine, and you would be charging that battery pack to produce the rotational movement. And it depends on, sometimes your energy can be clean, your electricity can be clean coming from renewables, or it can be not very clean coming from natural gas. It depends on how your country produces its electricity. This is the first type, the comparison between a thermal vehicle and electric vehicle, and we are looking at the powertrain. You need to remember this concept. The powertrain is the system that drives the movement in the vehicle. So let's look at plug-in hybrid vehicle. So the plug-in hybrid vehicle, it's a vehicle that you can fill it with fuel, but also you can charge it as well. And the difference between this one and the previous one, this has an internal combustion engine in addition to the electric machine, or in addition to a battery pack at least. So it has more complex sophistication. It has more complex arrangement in its powertrain. If we look at the hydrogen fuel cell electric vehicles, this is another clean car. It's not using electric vehicles, but it's using hydrogen. So you fill hydrogen in the tank, and it's being consumed in the fuel cell, and through an electric machines, it produces movement. So now we talked about the thermal car, we talked about the electric car, we talked about the plug-in hybrid car, and we talked about the hydrogen fuel cell vehicle. And there is the plug-in hybrid, and there is the hybrids, and the plug-in hybrid, you can charge it, while the hybrid, you can't charge it, but it uses battery pack as a power buffer and it utilizes regenerative braking. This lead me to this slide, which actually tells you between a conventional vehicle and an electric vehicle, there is a wide range of options, and this wide range of options can be a plug-in hybrid vehicle, or a full battery electric vehicle. And this would actually, it's affected by the type of engines you have in the car, the type of how you produce power, and it will affect how your powertrain is arranged. Now let's talk about charging infrastructure. We talked about the different types of electric vehicles. Now we need to talk about the charging infrastructure. So if you need to charge if you bought an electric vehicles, you need to have a charging infrastructure in place. You can have chargers at home, or you can have public chargers. And those charging at homes, you plug in your vehicle in the night, and you woke up in the morning to take it. They are called slow chargers. There are different kinds of chargers. Some of them are public, some of them are private. So the slow chargers, there are slow chargers and publicly accessible slow chargers and publicly accessible fast chargers. And you can see in terms of the number of chargers available in the world, you can see that China is leading the world in terms of number of chargers. The biggest two markets for electric vehicles, it comes first China, then the United States of America, then comes Europe. And here you can see pictures of a home charger, of a parked space chargers. This is a company called Zaptec. And here you have a bus charger that is using an overhead catenary. And here you can see, maybe this is a Tesla charger. I'm not sure about the company. It's a publicly accessible charger. So there is private slow chargers, and there is publicly accessible fast chargers and publicly accessible slow chargers. So let me tell you about the charging time. And for normal charging, you would need to have an 8 hours charge, and it's used for everyday charging depending on the range of your car. Accelerated charging has 1 hour, and fast charging, it might take 30 minutes or less. And sometimes they take 15 minutes to reach 40% of the battery, or 15 minutes to reach 30% of the battery. So the charging infrastructure, building this charging, as we talk about the ecosystem, is not only the vehicle, you have the chargers, you have the power renewable sources. You need to think about how you are going to build your chargers. And this is the government role, plays a fundamental role in advancing the application of chargers. Sometimes they provide funding, like Norway. They have the government has built most of the public chargers. Sometimes regulations which affect, for example, the building code. Sometimes the building codes, by making sure that every building in the city should adhere to have a charging place, a charging station in place, and this is called building codes. You might do this with standardization. We have a problem with the number of chargers that are the different types of plugs, and you can have you might do this with standardizing manufacturing of those chargers, and sometimes you do this by information, just having these information campaigns and awareness campaigns to try to explain the different concepts for people. So this is just some of the examples of how the government can help in providing a proper charging and electric vehicle schemes. If we look at there are two countries that I will give you some example. In Norway, the government has financed the charging infrastructure. So they have built most of the public available chargers. And in France, they have actually made a regulation that all buildings should have a charging outlets, or should incorporate electric cars charging in them. So with that, they have provided an enabler for the development of electric vehicles. Now, as I said before, it's not only, it's an ecosystem. It's not only the vehicle, it's not only the charger, but actually the grid itself is impacted. Your electricity grid is impacted. So in the morning, you have usually in your electricity grid, in the morning, you have a peak. People use their showers, watch the TV quickly before going to work, and they rise the demand for electricity. When they go to work, the demand is down, they leave their homes, then they come back in the evening and they start to use the energy again. If we add electric vehicles charging to this, so we will have a peak in demand for electricity. So, and we need to try to flatten the curve, or to at least flatten the curve is a concept that came from COVID-19. We need to try to at least decrease the demand by changing in time of charging, or providing smart metering, or providing or at least increasing the capacity of our energy grid. So now we talked about at least 3 components of the ecosystem and how electric vehicles will affect our ecosystem. So there is also another aspect that might affect grid and generation. There is a concept called vehicle to grid, which basically, if your car actually has, if your car battery has sufficient energy, you can actually charge the grid, return this electricity to the grid and charge the government for it. And if your car needs to consume electricity, it can take this, it can consume some energy from it, it can consume some energy from the grid. So this is called vehicle to grid technology. But also there is, if you are dependent on renewable sources, you might need something called a smart grid. And the smart grid makes sure that you have the demand regardless of the way you generate energy. Solar panels does not produce energy at night, and wind turbines does not produce energy when there is no wind. So by having a smart grid that combines different sources of energy, you can make sure that you can accommodate the demand of your electricity grid all the time. So finally, we talk about policy. Electric vehicle policy is still heavily influenced by public policy, by the government. So when I talked about the Vision 30, at 30% of electric vehicles stopped by the year 2030, this is something that is supported by different governments that want to reach 30% of their electric vehicles at least within the country. For example, countries like Norway already have 30% of their fleet coming from of their fleet is electric vehicles. Maybe they reach 56% or 60%. But to push the environmental agenda, you have to experiment with different policies, and policy can be indicative, can be, for example, we should adopt electric vehicles. It can be incentivized by money, like money rebates and providing bonuses on the purchases of car. It can be non-monetary, like having an access to shared cars lanes, or having a dedicated bus lane, or having free access to parking. And it can be normative as well. So there are different ways for thinking about policy and how you can promote electric vehicles within your country. Now, opportunities in electric vehicles. What are the opportunities that can happen from the revolution of electric vehicles? So there is a battery leasing scheme. Many, because the battery lasts for maybe 5 years, 6 years, 7, 8 years. Many car companies like Renault started to lease the battery. So you pay on a monthly basis for the battery. You buy the car and you lease the battery, like you rent the battery. So you purchase the whole car, but you're actually renting the battery and you pay on an installments. So this is one scheme. that is providing an opportunity for electric vehicles. Another one, battery recycling. With that number of batteries that are being used in electric vehicles, you need to find a way to recycle those batteries. You might be able to use those batteries in your car, or in the product or in your vehicle to grid technology, or in a new application. So the batteries that will be coming from electric vehicles, the recycled batteries, would provide an opportunity as an energy source for many other applications. Another opportunity is the vehicle-to-grid technology and metering. We talked about the grid system in the country, and when we talked about the grid system in the country, we talked about how we can at least reduce the demand by having smart metering, or by charging or by using the vehicle to grid, like sending electricity to the grid and charging for it. And this is just some examples of the opportunities that are available for electric vehicles. But also there is smart electric mobility. You can join this revolution by building or being part of a company that is building an e-scooter, or an electric scooter, or an electric bike, or an electric motorbike. There are many opportunities in terms of building micro mobility that is dependent on batteries, or that dependent on electricity as an energy source, in a similar way to the electric vehicles themselves. But also there are new business models. You can have these shuttles, you can have a spa car. So as a socio-technical change, electric vehicles will need to be to provide new services, and hopefully this happens with this autonomous revolution. So having shuttle buses or having electric cars is another way, or having new business models that is offering the service of electric vehicles will provide an advantage for many citizens, and many people will find they would like either to be part of this business, or to develop their own business, or to utilize it. New business models. So we have electric vehicles. How now the cost of driving is less. So you might have the concept of ride sharing or car sharing. Car sharing is a concept that is about having an electric vehicle. You can borrow it for a day or for a few hours, and those vehicles are parked around the cities, similar way to the way you rent a bike. So you just need a car for 2 hours. You can share it. You can go for one of the available shared cars. You just use your ATM card or your credit card. You pay for an hour or two, then you park your car somewhere else in the city. So new business models can emerge as a result of electric vehicles. Charging innovations, of course, now we have to plug in to charge our vehicles using a plug. And now we are seeing many devices can be charged wirelessly, and maybe there will be some charging innovations in the way we charge our electric vehicles, or how do we charge them as well. So this is some of the areas of innovations that can happen by understanding and knowing more about electric vehicles. Battery replacement services. Those vehicles has to replace their batteries from time to time. So, or of course, not only cars, but all different battery using devices or battery using systems. So battery replacement services might be useful for many, might be useful for, or might be a way, might be a business, or might be a venture that some young people would like to join or would like to learn about. So the future, and this is a chart by Siemens, and he means to tell you that today there is a driver and the car is a standalone. It uses a combustion engine and it's owned. However, the future is autonomous, connected, electric, and shared. So we talked about autonomous yesterday, and we talked about electric today, and also we talked about connected yesterday, and shared, we talked about shared today. So I hope that the Siemens future vision for the future aligns very well with what we have explained. So let me have a look at the questions. Main functions for civil engineers in this project. Basically, you would be, what are the main functions of civil engineers in this project? Basically, you would be accommodating charging, you would need to accommodate charging infrastructure in the city, as well as charging slots in your designs of buildings. This is where I see the civil engineering part. Are there any rules in place to process discarded electrical system, for example, batteries? I think there are some rules, but now there is a need for finding a cleaner way for providing renewable energy. I think I have read a report that is by the institute, or I think by the Energy Institute. I can't actually remember the name. By the I think the Global Energy Agency, or I have to check the name. And sorry, by IEA, the International Energy Agency, and they talked about renewables, and battery renewables has to be done in a new way. So what are the steps being done on battery waste management and how it can be reduced? Yes, this is the topic that I talked about. So I don't know the details, but what I know that the current practice is not clean enough, or it has to be adopted, and more recycling has to be done. So. But I would highly recommend that you read the International Energy Agency on this topic. What about a portable power bank? What about a portable power bank? You mean for cars? I can't understand this question. So, okay, so tell me about what about a portable power bank? Can you just explain this question? What do you mean by a portable power bank? For electric vehicles, wow, this is already exists. So, but it's not portable. It's a truck that comes and charge your vehicle wherever it is. So, if you mean this is one of the innovations. So, the way you charge your car, and the way, so instead of going to a charging station, there are some trucks that comes for you and charge it for you. And maybe you would have this if your workplace is not, and maybe you can have this if your workplace does not provide, for example, electricity charging, and you run out and your battery has run out. So maybe you go and you use this service where you request this portable charging truck to come and charge your vehicle. So we have a poll. How was your experience with the session? Are you interested in joining the courses on e-mobility and autonomous vehicles? Okay. So we leave you to answer the questions. So awesome. We have a lot of awesomes, and we have 3 people are interested in joining. Just use the car's passion look for Firas Nasser on Udemy, just write autonomous cars and you will find our course, and just use the Cobon cars passion. So thank you. So we got around 7 answers. So 75 8 answers, 75% that they think the session was awesome, and 25% thinks it as expected. And are you interested to join the course on e-mobility, autonomous vehicles? Yes, we have 89%. All what I can say, you just go to Udemy, type autonomous cars, you find the course that is lectured by Firas Nasser. It's the famous Waymo car, the white car, and you use the Cobon cars passion. So we'll end the poll now, and let me share the results with you. And now we need to start our career. How you can start a career in electric vehicles. So there is a big, many companies that are pushing for electric vehicles, and those are the automakers. So the automakers, you can find one of the big automakers and join their electric vehicles program. And many of those automakers produce their own electric vehicles model. So it's in a very much similar in how you actually enter an automaker company. But having the knowledge will help you in your job, as well will help you in your understanding and in getting a job. So that's starting a career. And of course, you can work for the government if you work in policy. So there are many NGO, many government organizations that work on pushing the environmental agenda and focus on aspects associated with electric vehicles. And or you can work with business. You can be working with a trader selling electric vehicles or selling the components of electric vehicles. But also you can join a startup, and there are the startups of electric vehicles work in so many domains. You can work on producing a passenger vehicle, the passenger vehicle itself. You can work in charging infrastructure. You can work in the optimization of lithium-ion batteries or in the development of batteries. You can work on solid-state batteries, supercapacitors, battery management and analytics, fleet management if needed, charging networks, charging station management, software, end-of-life battery tech, vehicles to grid tech, commercial vehicles, mobility services. So this session is just an introduction for the world of electric vehicles, and you would be able to enter this market in a new way, and you will be able to be part of the electric vehicle revolution, and you might be able to build your startup based on your understanding on what kind of problem you feel you need to tackle. I think that this is one example of a company that I have seen growing from nothing, building their own charging solution. Zaptec is a good example of an entrepreneurship company that have ventured in the world to the world of electric vehicles. They are providing charging solution for homes as well as for the publicly accessible chargers, as well as home designed chargers. With this, we conclude the course Cobon is Cars Passion. We talked about various opportunities in electric vehicles. We have explained the electric vehicle ecosystem and EV policy. We talked about innovation using EV technology, and we talked about starting a career in the EV world, as well as entrepreneurship in electric vehicles. I will answer some of your questions now. So thank you. There was a few comments. Thank you. So I thank that, and back to you, Amit.
Thank you, Ferris, for another engaging session on e-mobility. Yesterday we started with autonomous vehicles, and today we concluded with e-mobility. It was a great session, insightful session. And guys, we will be soon starting and inviting Ferris to our platform at LabDocs, and all the courses that you see will be there at our platform as well, and we will continue to provide value to you. And I hope that you will take great benefit out of this. So thank you, Ferris, for taking out time
You
and
are welcome.
on a Sunday and helping us in this initiative. And thank you everyone for joining us. And we will be seeing you soon. So
It
take
was my
care and use the coupon to get the discounted course over there.
sure.
So great to have you, everyone. Thank you.
My pleasure. Thank you very much. Take care for now.